Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Pluto, the uncharted frontier. Once considered the ninth planet of our solar system, Pluto's story is one of discovery, reclassification, and ongoing exploration. The journey of Pluto began in 1930 when Clyde Tombaugh, a young astronomer working at the Lowell Observatory in Flagstaff, Arizona, identified a distant, faint object moving across the sky. This discovery was the culmination of a search initiated by Percival Lowell, who had hypothesized the existence of a planet X beyond Neptune to account for perceived discrepancies in the orbits of the outer planets. Tombaugh's meticulous work paid off when he captured images of a distant body, confirming the existence of a new planet. This newly discovered world was named Pluto, following a suggestion by an 11-year-old girl from England, Venetia Burney. She proposed the name in reference to the Roman god of the underworld, fitting for such a distant, dark place. For over 70 years, Pluto was considered the ninth planet of our solar system, orbiting the Sun in a region known as the Kuiper Belt, a vast expanse filled with icy bodies and remnants from the solar system's formation. Pluto's status as a planet was widely accepted, and it captured the imagination of astronomers and the public alike. Pluto is a small, rocky, and icy world, significantly smaller than Earth's moon, with a diameter of about 2,377 kilometers. It orbits the Sun at an average distance of approximately 5.9 billion kilometers, taking about 248 Earth years to complete one orbit. Its orbit is highly elliptical, sometimes bringing it closer to the Sun than Neptune, a fact that intrigued astronomers and added to its mysterious allure. One of the most notable features of Pluto is its composition. Pluto is primarily made of ice and rock, with a surface covered in a variety of ices, including nitrogen, methane, and carbon monoxide. This composition gives Pluto a distinct appearance, with a surface that can appear bright and reflective due to these icy materials. The temperature on Pluto is incredibly low, averaging around -232 degrees Celsius, cold enough to freeze most gases into solid ice. Pluto's surface is a complex and varied landscape, with regions of mountains, plains, and valleys. One of the most striking features is a vast, heart-shaped region known as Tombaugh Regio, named in honor of Clyde Tombaugh. This region is divided into two distinct lobes. A western lobe composed of nitrogen ice called Sputnik Planitia, and an eastern lobe covered in methane ice. Sputnik Planitia, in particular, has captivated scientists due to its smooth, relatively crater-free surface, indicating that it is geologically young and active. The discovery of Pluto's moons further added to its intrigue. In 1978, astronomer James Christie discovered a large moon orbiting Pluto, which was later named Charon, after the ferryman of the dead in Greek mythology. Charon is about half the size of Pluto, making it one of the largest moons relative to its parent body in the solar system. The discovery of Charon allowed astronomers to learn more about Pluto's mass and density, providing important clues about its composition. Charon and Pluto share a unique relationship. They are tidally locked, meaning they always show the same face to each other as they orbit a common center of gravity outside of Pluto itself. This binary system is unique among the planets and their moons in our solar system and has fascinated astronomers and planetary scientists. The discovery of additional moons in the early 21st century added more layers to the story of Pluto. In 2005, two small moons, Nix and Hydra, were discovered by the Hubble Space Telescope. These moons are much smaller than Charon and orbit Pluto at greater distances. Further discoveries followed, with the identification of two more small moons, Kerberos and Styx, in 2011 and 2012, respectively. These discoveries highlighted the complexity and richness of the Pluto system, suggesting that it had a more intricate history than previously thought. Despite its fascinating characteristics, Pluto's status as a planet came into question in the late 20th and early 21st centuries. The discovery of numerous other Kuiper belt objects, some of which were comparable in size to Pluto, led to a re-evaluation of what constitutes a planet. This debate reached a climax in 2006 when the International Astronomical Union, IAU, redefined the criteria for planetary status. According to the new definition, a planet must orbit the Sun, be spherical in shape, and have cleared the neighborhood around its orbit. Pluto met the first two criteria but failed the third, as it shares its orbital space with other Kuiper belt objects. As a result, Pluto was reclassified as a dwarf planet, a decision that sparked considerable controversy and debate. The reclassification of Pluto did not diminish scientific interest in this distant world. In fact, it fueled further exploration and study. In 2006, the New Horizons mission, a NASA spacecraft, was launched with the primary goal of conducting a flyby study of Pluto and its moons. After a journey of nearly a decade, New Horizons made its closest approach to Pluto on July 14, 2015. Providing humanity with the first close-up images and detailed data about this enigmatic world. The data and images sent back by New Horizons revolutionized our understanding of Pluto. The spacecraft revealed a world far more complex and dynamic than previously imagined. The detailed images of Pluto's surface showed a diverse landscape, including vast plains, towering mountains, and intricate patterns of ice and rock. The heart-shaped Tombaugh Regio, with its smooth, bright plains, suggested recent geological activity, possibly driven by the slow convection of nitrogen ice. The presence of mountains made of water ice, some rising as high as 3,500 meters, hinted at a surprisingly robust internal structure. New Horizons also provided valuable insights into Pluto's atmosphere. It detected a thin, extended atmosphere primarily composed of nitrogen, with traces of methane and carbon monoxide. This atmosphere is subject to seasonal changes, expanding when Pluto is closer to the Sun and contracting as it moves further away. The spacecraft's instruments measured the escape rate of atmospheric particles, providing crucial data on how Pluto's atmosphere evolves over time. The exploration of Pluto's moons by New Horizons also yielded fascinating discoveries. Charon, with its rugged, varied terrain, featured a massive canyon system, possibly formed by the freezing and expansion of a subsurface ocean. The smaller moons, Nix, Hydra, Kerberos, and Styx, were found to have irregular shapes and chaotic rotations, adding to the complexity of the Pluto system. Pluto's reclassification as a dwarf planet has not diminished its scientific significance. It remains a subject of intense study and interest, providing valuable insights into the processes that shape the outer solar system. The data collected by New Horizons continue to be analyzed, offering new perspectives on the formation and evolution of icy worlds beyond Neptune. Pluto's story is one of discovery, re-evaluation, and exploration. From its initial identification as the 9th planet of our solar system to its reclassification as a dwarf planet, Pluto has captivated astronomers and the public alike. The New Horizons mission's flyby provided unprecedented insights into this distant world, revealing a complex and dynamic landscape shaped by geological and atmospheric processes. Despite its reclassification, Pluto remains a key piece of the puzzle in our quest to understand the outer reaches of our solar system. Its story is a testament to the ever-evolving nature of scientific knowledge and our relentless curiosity to explore the unknown. Pluto's status and significance extend beyond its physical characteristics and scientific data. It has become a cultural icon, representing the idea of exploration and the quest for knowledge. Its demotion from planet to dwarf planet sparked public debate and a renewed interest in astronomy, highlighting how our understanding of the universe is always subject to change as we gather more information. The exploration of Pluto has also paved the way for future missions to the outer solar system. The success of New Horizons demonstrated the feasibility and value of exploring distant, icy worlds. It has inspired new proposals for missions to other Kuiper Belt objects and even more distant targets in the solar system. These missions aim to further our understanding of the diversity and complexity of these remote regions, shedding light on the processes that shaped our solar system's formation and evolution. In addition to scientific exploration, Pluto has inspired artistic and literary works, capturing the imagination of people around the world. Its distant, mysterious nature has made it a symbol of the unknown and the potential for discovery. Stories, poems, and visual art have all drawn inspiration from Pluto, reflecting humanity's enduring fascination with this distant world. Pluto's journey from discovery to reclassification and exploration is a microcosm of the broader scientific process. It illustrates how our understanding of the universe evolves as we gather new data and develop new theories. Pluto's story is a reminder that scientific knowledge is not static but constantly changing as we push the boundaries of what we know. As we look to the future, Pluto remains an important subject of study. The data from New Horizons continue to provide valuable insights, and future missions may uncover even more about this distant world and its place in the solar system. Pluto's story is far from over, and it will undoubtedly continue to play a significant role in our quest to understand the outer reaches of our cosmic neighborhood. In summary, Pluto's narrative is one of exploration, discovery, and reevaluation. From its initial identification as the 9th planet to its reclassification as a dwarf planet, Pluto has fascinated scientists and the public alike. The New Horizons mission's groundbreaking flyby provided a wealth of data, revealing a complex and dynamic world with diverse geological features and a tenuous atmosphere. Despite its reclassification, Pluto remains a key object of study, offering insights into the processes that shape the outer solar system. Its story is a testament to the evolving nature of scientific knowledge and humanity's enduring curiosity to explore the unknown.